That's because I just got back from the dentist, so you're having definitely a little bit better day than I'm having. So anyway, with that said, let's take a look at a little bit of housekeeping stuff on the 250 Toyota. First off, we'd like to thank the guys from Seal Aftermarket Products for helping us out, obviously, with sponsoring everything. On the connection side of it, make sure, again, you're a hardwired style connection, not a wireless connection. The handout itself, I've actually updated the handout as compared to what you guys pulled in when you signed up for the class. So you can go to the website again and pull in the new handout. I just sent it over to Sean today, so it should be up either this afternoon or tomorrow morning. You should have the new handout up on the site so that you can actually pull it out. So the guys who are obviously attending the webinar today are going to be at an advantage as compared to those guys who just tried to download the webinar handout itself and not actually attend the webinar, since the handout actually changed. So if you got questions, we're going through this stuff today, feel free to ask it. I'll try to answer it for you. The simplest way to do that is to click on the questions box, type your question in, hit the submit key. It's going to automatically pop up on my screen, and I will try to answer whatever questions you have about the subject we're talking about. The survey itself is an automated survey, follows everything. When we're all said and done, we'd love to hear back from you. If you have any questions about ATRA or you'd like to become an ATRA member, feel free to give Lance an email at lwiggins@atra.com. He'd love to hear from you. Now, I'd like to send out a special thanks to Bob from Valve Body Pros. Bob was the reason I obviously updated the handout. I was at one of the seminars, and Bob was there, and I asked him if he had any information he could share with us on the U250. And he said, yeah, he had some really nice pictures of some valveware, some common things that they run into. So you're going to see a bunch of the Valve Body Pro pictures up here that Bob provided for me. So again, a big thanks to him because, again, that makes everything more relevant and it makes a better quality presentation for you guys. Now, the U250 has been around for a while. As you can see, it is a very common transmission for Toyota, used in their most common vehicle, which is, of course, the Camry. It's also used in the Avalon, Solara, and, of course, many Lexus applications. There is a difference in models of these U250, just so everybody's aware. They made a pretty major change to the hydraulics in these transmissions in 2007. So effectively, we're going to take a look at both valve bodies, so you get a chance to take a look at each one. As you can also see, the late model U250s all use type WS fluid, or the early model use type T4 fluid. So again, a little bit of difference. Give me a clutch and brake apply chart. The clutch and brake apply chart itself is so that you can obviously have some background information if you're trying to diagnose one of these for what's actually on when. And now we're going to spend a little bit of time on what's different about this transmission. Now, most of you guys were with me when we did the 6L80 webinar, and we also did a 760, 750, 761 webinar on the rear drive Toyotas. Both of those applications use this technology. Toyota calls it a centrifugal fluid pressure canceling system. GM called it the compensator circuit. Same exact thing. We're going to put oil pressure into a separate chamber within the piston assembly to aid the return springs in shoving the piston back. The early model 250s had check ball capsules in the drum. The late model ones do not. They use this pressure canceling system that Toyota has designed for their units themselves to shove the piston back so centrifugal force cannot reapply the piston itself because of oil trapped in the drum. So the system itself is very simple as far as operation. You can see the balance piston in the picture you have popping up right there. So the pressure actually goes in between those two pistons right where those return springs are located at. A real simple hydraulic schematic of how this actually works is right here. As you can see, the red oil, that's going to be your apply oil. The blue oil, that's going to be your balance oil. The blue oil is provided from your lubrication circuit. So they actually use the lube oil to come in to help push the piston back. So the lube oil is working in the same direction that the springs for the clutch pack are working. So again, the idea behind this is that you don't have to have check ball capsules in anything anymore or orifices in the clutch drums anymore. You can simply use pressure that's already there to shove the piston back. Here's a look at exactly where that oil is going. So as you can see, you've got your overdrive balance piston and, of course, your overdrive clutch piston, and then the return springs that sits between the two of those. That lube oil is being pumped right in between the two of those pistons. That, of course, is what's shoving that whole overdrive piston down into that drum that you see right there. Now, one of the other things that pops up on these transmissions is there's a lot of misinformation out there regarding which solenoids are which. I've seen lots of diagrams that were not correct. Not sure how they ended up coming out, but they were not correct as far as which solenoids were actually which application. So I've given you a chart to show you exactly which solenoid is called out in the chart. So this chart is the correct chart. Now, one of the things I might warn you also about when it comes to the U250, same thing we talked about when we talked about the 750, 760 series. A lot of these linear solenoids look identical, or very, very close to being identical. You need to make sure you mark them before you pull them out. If you fail to do that and you get them mixed up, it's going to be a really bad day for you. So bottom line is, make sure you take the time to mark everything so that you can get it back together the same way that it came apart. I will show you a method that they're using at Valve Body Pros, so if obviously they end up getting mixed up, you at least have a chance on unmixing them, I guess you might say. Now, the solenoids are also called out by a couple different names. As you can see, we got the repair manual information as well as the parts manual. So here's the two different names. Depending on who you're talking to will determine which terminology you actually use to describe the solenoids. And as I told you, if for some reason you did not mark these solenoids and you pulled them out, Valve Body Pro has developed a process for IDing some of those solenoids. That's what's on the bottom of the page right now. So they look at the number of slots next to the electrical connector and then use that for their identification process. The wiring in this transmission, as you can see, is all color-coded with connectors. So again, this is the orientation of the wiring in the U250. The pressure regulator is adjustable just like it was in the 700 series Toyota transmissions. So again, nothing different than you've heard us talk about before. Make sure you mark the pressure regulator valve prior to pulling it out of the board so that you know you get it back in at exactly the same location. This would affect your baseline pressure, so you want to make sure that this thing goes back in where it's supposed to be. As I talked about earlier, there's a couple different valve body configurations for this transmission. We're showing you the late model valve body configuration right here. And one of the things we're talking about, we're showing you the different valves. I'm going to show you several pictures of this. These valves are real common wear items. Any sleeve you see in any of these U250s, make sure that you check the sleeve for wear. Most of the valves we're having troubles with. If you're dealing with a transmission that has more than 50,000 miles on it, almost guaranteed you're going to see something worn out in this valve body. We've had troubles with the end plugs that are there on the ends of the valves. We've had troubles with the sleeves. We've had troubles with several of the valves physically wearing. So again, you need to make sure that you take your time and go through it and check all this stuff for wear. Now, how you check it's totally up to you. The most accurate method, of course, is a vacuum check. But a lot of guys don't have a vacuum test tool. So how else can you check it? You could check with a flashlight. You could measure it. Some people hydraulically check it. Some people air check the circuit itself. So again, lots of different theories out there of how to actually check the valves. Whatever you do, at least check them. I don't care how you check them, but at least check them. Now we look at, well, hopefully we're going to look at, yeah, here we go. We look at the next picture that pops up. Again, we're showing you some of the more common valve orientations as we rotate the valve body around. So the legend on the left-hand side, again, shows you which valves we're calling out there in the picture. We rotate the valve body some more. You're seeing, again, some more of these sleeves we talked about. So here's my B1 sleeve, my B2 sleeve, my pressure regulator valve sleeve, and so forth. Again, these sleeves and several of these valves are very common wear items. So I can't overemphasize how important it is that you check those devices for wear. Here's a look at your earlier valve bodies. That's the 2005, 2006 applications, again, which is different from what we just showed you here previously. The check balls in this transmission, there's a couple sets of check balls. A couple are large check balls, as you can see here, 394 thousandths. And then, of course, on the other side, we actually have some regular balls, some regular check balls. These check balls that we're seeing right here are all black in color. The black balls were the balls that in turn were wearing out. So what we're saying is you're going to have to update from the black balls to the blue balls. So the blue balls are the updated check balls. Our position on this transmission is the same as it is on a 6L80, 6L90, and that is if you got one apart, put the balls in it. So always order a ball kit, whether your kit that you're ordering services the balls or not. Always make sure you're putting a ball kit in these transmissions. The torque converter clutch check valve is the last valve we're looking at here. Make sure, again, that you check that check valve. Make sure it's nice and snug in the bore, the springs installed the right direction. If that valve is leaking, you're going to end up with converter charge issues. So, again, it's going to be a real bad day if somebody misses and doesn't check that valve to make sure that it's sealing. As we talked about with the 700 series Ison transmissions, again, accumulator pistons are wear items in these transmissions. This design is the same as it is in those other transmissions we talked about. So again, you're going to have to make sure you check the accumulators and the accumulator bores for any type of evidence of wear. Now, the solenoids, of course, are one of the areas of this transmission that kind of stumps people because they look very, very, very similar. You can see the slots on this solenoid right here. This particular one here has 5 slots in it lined up with the electrical connector. That's what we're talking about for ID there. They have different slot counts depending on which solenoid it is. But again, a lot of guys don't know which solenoid is which. And so all of these are linear solenoids. So what's that basically mean in simple terms? That means it is changing pressure corresponding to changes in amperage. So amperage and pressure are related to each other. So as the current changes, the pressure changes. So it's really quite simple. When you look at the legend at the bottom, the reason I put that legend in there on the bottom is so you know which solenoid is responsible for what. Because again, guys just don't know exactly what those solenoids do, so this legend will help you out if you're struggling with this a little bit. So you know that an SL1 is in charge of the B1 brake. You know that an SLT is in charge of your line pressure and so forth. So again, that will help you out a little bit with figuring out what the solenoid is actually responsible to do. Now you also have a couple other types of solenoids in here. This is actually the 3-way solenoids like we talked about in the Ison 700 series transmissions. They've got them in this transmission also. Again, so you can control pressure a couple of different ways here. We're going to take a look at a typical shift valve and how that would actually function. So in this instance, they're actually using the solenoid and the shift valve as a shuttle valve train to shuttle the oil pressure between 2 different clutches. So on the left-hand side of the page, you can see my shift solenoid number 4 is in the off position. So we now have no pressure coming to the base of that shift valve. The spring at the top end of the shift valve loads the shift valve down, and we end up with line pressure going over into the B3 clutch, turning the B3 clutch on. When we want to turn the C3 clutch on, what we do is we turn on, as you can see there, the shift solenoid number 4. So we turn shift solenoid number 4 on, pressure builds up at the base of that 4-5 shift valve, shoves that shift valve all the way up, which in turn then shuttles the oil from the B3 clutch up into the C3 clutch. So that's the basics of how these different types of shift solenoids are actually functioning. They actually do more than one simple function here. Now, like any other transmission, you're going to have some electrical inputs to your controller to make the controller obviously understand how the vehicle is operating. I'm giving you a list of obviously these controller inputs that the 250 uses. The controller then makes a decision based on what the input information is and then commands an output action to occur. So just like any other transmission, folks, if you're having a problem with the output either not working or a problem with the output basically being skewed, like for example the pressure's not doing what it's supposed to do, you need to look at the input side before you start tackling the output side. It very well could be an input issue like a sensor or a switch that's causing you the problem, and not necessarily a problem with the solenoid itself or valve train or anything else like that. Now, we got a block diagram that kind of shows you how the inputs and the outputs physically work. So that's just a little correlation diagram to help you understand where those bits of information are actually going to. Now, this transmission is going to have a series of trouble codes just like all other transmissions do. And you can see I've broken it down into either performance codes or electrical codes. An electrical code means that you either have a problem with the solenoid electrically, the wiring electrically, or the controller. That's what those codes basically mean. That means you could not have a problem with the valve causing the electrical code. Could not have a problem with a clutch causing electrical code. That's what the performance codes are about. So the performance codes themselves are actually there to check the operation of the hydraulic system and the mechanical system in the transmission. So as you can see, we break these apart based on code numbers, and if it, again, is a performance issue, you're certainly not going to be looking at the wiring. If you have an electrical issue, you're certainly not going to be yarding the valve body off looking at the spacer plate. So that's the basics of what we're dealing with here, just like we will with other transmissions. Now, as I told you when we first started, we're going to spend a lot of our time on product issues today. So let's jump into some of the product concerns we're going to see. The most commonly worn valves in this transmission are these guys right here. Your boost valve, your B2 valve, your B1 valve, all the lockup valve train, the accumulator pistons and bores, and the in plugs. Now, one thing I did not put in here, I should have put in here, is the pressure regulator valve train. You got a couple pressure regulator valves. Very common that those valves physically wear out. So again, bottom line is lots and lots of things to look at for wear when you get one of these transmissions apart. Again, anything past about 50,000 miles, it's subject to being physically worn, so you have to inspect it. So the more miles and the less oil changes this guy has done, needless to say, means that you're going to have to probably service more valves. Now, Bob provided me some really neat pictures here, which is great because, again, it really helps to actually have a good picture so you guys know exactly what you're looking at here. So in this instance, we're looking at the accumulator pistons. You can see the damage on the accumulator pistons. Bottom line is there are kits that are out there from several different manufacturers to address this as an issue, rather than have to put a whole valve body assembly in the transmission itself. We're going to have lots and lots of valves to look at. So in this instance, we got the valve body rotated around. You can see I've got the secondary regulator valve, got a TCC valve, I got the solenoid modulator valve. Again, all of those valves are subject to wear issues. The sleeves on these valves are subject to wear. And of course, the in plugs like to leak. So bottom line is you need to look at this stuff very, very, very closely. You know, we don't think about things like that solenoid modulator valve causing us troubles. Well, that's actually what's controlling your solenoid pressures. So if you're in turn having a problem with that valve, you're going to have problems with the solenoid operation. So again, bottom line is we need to check those valves for physical wear, check your sleeves for physical wear. Your B2 and your B1 sleeve, very common issues for wearing out. So he got me a really nice picture, as you can see here, of the sleeve being physically worn. So you can actually see the wear on the inside of the sleeve itself. Pressure regulator valve. This picture on the right-hand side showing you the head of the regulator valve, that's a really cool picture because if you look at that really closely, that thing's worn so bad that it's tapered. So basically there's a taper built into that valve. And bottom line is there's not supposed to be a taper built into that valve. So the valve can look nice and shiny, but physically be worn out. That's the whole point of this. Or the bore the same way. The bore can physically be worn, even though the bore seems to look pretty good. So again, how you choose to check it is up to you, but simply make sure you check it. We're looking at the boost valve on the bottom left-hand corner of that picture. As you can see, the boost valve itself wears out the sleeve, and in this instance, we've got some scoring that you're seeing in the valve itself. Now, let's look at some other issues. As we talked about a little bit earlier, we've had some check ball changes. They originally came out with black colored check balls. We've changed that over to the blue colored check balls because they're a different material. Bottom line is that anytime you get one of these transmissions apart, it would behoove you to physically go through and put check balls in it. Very cheap insurance to make sure you do not have a problem. So if your particular supplier is not supplying you with check balls, my words of wisdom is order a check ball kit. Shuttle or bind up on a 2-3 shift, very common issue you run into. So in other words, it ties up on you when she makes the gear change to third gear. If you have a problem with that, take a real hard look at the direct clutch control valve for physically hanging up. There might be debris on it, valve might be worn, side loading in the bore, who knows, but the bottom line is we've had some troubles with that valve train physically hanging. 07 Camry hard shift concerns. So we're talking about an 07 Camry. We're giving you the engine code that you've got, and we're saying there's an updated calibration. Now, one thing I might give you a heads up on this calibration thing. There are some of the earlier model Camrys and so forth that they didn't actually have cal capabilities. You actually got the different cal by replacing the controller. So just be aware that you may be able to recal, you may not be able to recal depending on your year. Now, this particular one here, there's actually a recalibration for. So go through, make sure you're within the VIN brakes themselves, and if you are, physically do the update on the cals. Guys who are not doing calibrations are losing money. I'm just here to tell you. This stuff is not going to go away, doing the calibration thing. You're going to see that even to change a solenoid on many transmissions, that it's going to become a necessity that you recal for that. So again, you cannot run away from this stuff. It's not hard to do. It doesn't take a huge investment financially. Not much you can really screw up with it. Very easy process, and it's some of the best money you'll ever make. So with that said, most of you guys were with me. We went through the GM calibration webinar, Ford and Chrysler calibration webinars. I'm going to be following this up, guys, on the 4th of June with a Toyota calibration webinar. So we're going to teach you how to do calibrations on Toyotas on the 4th of June. So if you'd like to attend, we'd love to have you. All right, next little situation here. Hard downshift, 2005 to 2009 transmissions. As you can see, we're giving you some different mile per hour ranges. This is not a problem with calibration. So if you read through what I've written down here, this is a problem with the solenoid itself. So there's actually an updated solenoid part number for the SLT solenoid. So again, there's your part number for the solenoid. It's a wham bam, thank you ma'am kind of thing here. Put the solenoid in and you're out to get lunch with the car. Some more, obviously, shift concerns. This happens to be 04 and 05 Camrys, talking about problems between 10 and 30 miles an hour. Now, what I did in these charts, just so you're aware, I tried to make sure everything that was a cal number update I put in blue. So both 04 and 05, giving you both different engines that were available for those years. Your cal number updates are actually what you see physically there in blue. So this is a calibration change to fix the issue with this car. Again, more and more and more things are being fixed with calibration. Less and less and less things are being fixed with physically changing pieces. Hard shifts during acceleration, 07s to 09s. As you can see here, we got a calibration change. We're showing you where the cal breakoff point was out on the VIN code. And the next page is going to show you the actual updated cal numbers. So if you weren't within those VIN breaks, then you actually have to go through and make sure that your calibration was actually updated in your vehicle. So you're going to go to your cal ID information on your scan tool, look at the cal number, make sure it's got the correct cal in the vehicle. These next ones are going to be very interesting for you because, again, most people don't associate a calibration issue with a speed sensor issue. This happens to be a code 500 right here, P0500. We're starting out with these earlier model years that I'm going to go through, but basically every one of these that you see a code 500 with, there's a recal for. I just simply broken them apart to try to make it easier to see on your screen. So right now we're doing the 02s and 03s. As you can see, to fix this, it does not take a new speed sensor. It doesn't take any messing with the wiring. It is simply a calibration update. The window for the DTC was too narrow, causing obviously the DTC to latch. We look at an 05-06. Again, same exact complaint, P0500. Guess what? We got a calibration update. So bottom line is, guys, that you have an updated calibration to help you out with addressing this P500 code. 05 to 07 Avalons and a few of the other Toyotas, again, same exact thing. Again, you've got an updated calibration to try to address this issue. So anytime you see this P500, you need to take a real hard look for an updated cal. P0748, 798, 985, 986 on your Camry applications, as you can see here. These are all electrical codes related around shift solenoid E or the pressure control solenoid. Bottom line is there's an updated controller. They were having some issues with the driver circuits for these solenoids. So they've updated the controller itself. So this is a PCM replacement in this instance. Well, that pretty well covers our webinar for today. Let me see if I can get this thing back up here, guys. Pretty well covers our webinar for today. I hope you guys have enjoyed yourselves. Again, thank the guys at CL Aftermarket Products for helping us out with the webinar. And I appreciate everybody's attending this thing. So I can't get my one screen to pop back up, but I think we're pretty well done. So with that said, guys, have yourself a great day, and we'll see you next time.